if I said to you, come up with a function that satisfies f of 1 equals 2 and f of 5 equals 10. If I said to you, come up with a function that satisfies f of 1 equals 2 and f of 5 equals 10, could you do it? Okay, what would it be? F of x equals 2x would be one solution. Is this the only solution? It's a very simple solution. This is a great solution. I just want to tell you there are infinitely many solutions, right? Could you tell me another solution? I could also say f of x is equal to 2 if x is less than 5, and it's equal to 10 if x is greater than or equal to 5. Would this also meet the criteria? This is what's called an underdetermined problem. And the reason it's called underdetermined is you don't have enough information to say there's only one solution. Now, that doesn't mean it's a bad problem. It's just that you know at the outset that there are many different possibilities. Often, if you have an underdetermined problem, what additional information could you have that would make it so f of x equals 2x was the only solution? Yes, if you said come up with a linear function that satisfies this, or if you said come up with a function where the rate of change is constant, then that would be a different problem. And that problem, f of x equals 2x, would be the only solution. So the information that you have here, we had two pieces of information. We did not have the information that the rate of change had to be constant. Now, it's also possible to have what's called an overdetermined problem, which means that you have so many constraints on the problem, it's actually not possible to solve it as it's stated. So an example of this would be give a linear function that passes through 1, 2, 5, 10, and 6, 15. Can you actually do this? Pieces of information you need to satisfy. It needs to be linear. This needs to be a point on the graph. 510 needs to be a point on the graph. 615 needs to be a point on the graph. And it's not possible to do all four of these things simultaneously. There's too many possibilities. This notion that something can be an underdetermined problem or an overdetermined problem is really something you'll see a lot more in math. How does this relate to calculus 1? Well, what if I know the rate of change of my function? What if I know the derivative, but I don't know the original function? So what if I gave you a problem that was something like find f of x with f prime of x is equal to 2x. This is a constraint that the function needs to satisfy. When I take the derivative, I need to get 2x. Let's see, so one solution that I'm hearing is f of x is equal to x squared. Do you agree with that? And you said another solution is f of x equals x squared plus 5. So on both of these, if I took the derivative of x squared, I get 2x. If I took the derivative of x squared plus 5, I get 2x. Do you agree? This is currently underdetermined, which doesn't mean it is unsolvable. It means there's multiple answers. In fact, it means it's solvable and it's like you have lots of options. So there is a general solution though. I'm not going to be able to just do whatever I want. I'm not going to be able to like cosine of 4x. The general solution would be f of x is equal to x squared plus a constant. So x squared plus any number will satisfy this. This is called a differential equation because derivatives measure the difference between things. Derivatives measure change. So this is a special type of functional description where I know the derivative. And this f of x equals x squared is called an antiderivative for 2x. Why is it called an antiderivative? Yeah, it's like the reverse derivative. You're not taking the derivative, you're thinking, what would I take the derivative of to give me this? Does that make sense? Let's do find g of x with g prime of x is equal to 3x squared. Let's do this one first. I realize this one is a bit basic, but can you tell me the solution of this first? So you said g of x is equal to x cubed plus some constant. And we can just write c for the constant. We don't know what it is, and it doesn't matter. This is the general solution of this differential equation. Now, when they're simple like this, it's not too bad, right? But what if I give you something complicated? What if I said, find, and maybe this one will turn out not to be complicated for you, I don't know. And what if I said something like, find h of x that satisfies h double prime of x, the second derivative, is equal to h of x. Yeah, h of x equals 0 is absolutely a solution. Nice, good job. Nice job. That's another solution. It's not gonna work for it to be a constant that's not 0. Like, the only way you get through these things is to generate these ideas. You can't be right and fast consistently. No one can. Either you're right consistently, but you take your time, or you're fast consistently and you just accept a certain error rate. Either one of those will get you where you want to go. It's not possible. The other one that works is h of x equals e to the x, because the derivative of e to the x is e to the x. So when you take the second derivative, you would get e to the x again. We're going to be able to solve these for the most basic cases, but you can spend your entire life. What if I said b prime of x is equal to 2x, but I have an additional piece of information. I have an additional constraint. I also know that b of 1 is equal to 5. So now I know two pieces of information. Can you find a b of x for this? From b prime of x equals 2x, we know that b of x has to be equal to x squared plus some constant, because we're doing our reverse derivative. Now, I'm just going to write that as b of x equals x squared plus c. And now let's look at this additional piece of information. This b of 1 is equal to 5. b of 1 is equal to 5. Well, b of 1 is equal to 1 squared plus c. So this has to be equal to this, which means 1 squared plus c is equal to 5. And if I solve this algebraically, I get c is equal to 4. Plug that back in, and I get b of x is equal to x squared plus 4. Now, is there more than one solution here? This is going to be the only solution. Additional piece of information made this not be underdetermined anymore. Now there's only one. So we're going to spend basically the rest of the class on